Rewrite the following equations without using the inverse notation. Find x if possible. If not, explain why. All of these three equations have the inverse notation. Specifically, this is inverse sine or arc sine. The question is asking us to rewrite these equations without using the arc sine or sine inverse notation. Using the definition of arc sine or sine inverse, we have sine of pi over 3 equals x as an equivalent equation to the given equation. But this equation that we just wrote, sine of pi over 3 equals x, does not have the inverse notation. And from the unit circle, we know that sine of pi over 3 is root 3 over 2. And so x equals root 3 over 2. For the second part, similar to the first part, we have sine of x equals negative 1/2. We're looking for an angle x such that sine of that angle is negative 1/2. This is an angle in the fourth quadrant only because sine inverse is only restricted to the first and the fourth quadrant. Specifically, this angle needs to be from negative pi over 2 to 0. Sine of x is the y coordinate, so we draw the line y equals negative 1/2, and we see from the unit circle the angle that will give us sine of that angle, a value of negative 1/2, is x equals negative pi over 6. Notice that sine of pi over 6 is positive 1/2, but sine of negative pi over 6 is negative 1/2. And lastly, we rewrite this as sine of 3/2 equals x. But we know that 3/2 is not a special angle, so we cannot use the values from the special angles from the unit circle. So we would use a calculator. Sine of 3/2 is sine of 1.5, and so x is approximately 0.9975, where the angle theta equals 3/2 or 1.5 is in radian by default. When we use a calculator, we set our calculator in radian unless specified otherwise. In an unrelated note, if this problem is sine inverse of 3/2 over x, which is not related to part C, then we would rewrite this as sine of x equals 3 over 2. And in this case, there is no such x because sine of any angle is always between negative 1 and 1, and 3/2 is more than 1.